Hello everyone. In this video I am going to teach you about what is time complexity and space complexity. This time complexity is how much time it takes, how much time the program takes to complete its code till its execution. That is till its runtime. How much time it takes. That is called time complexity. Next is space complexity. Space complexity is how much space, that is how much memory or storage it takes to store the data in that data structure. That is called space complexity. We used to find this time complexity and space complexity in every programs we write, because suppose if I am writing a linear search program, in that program it takes o of n time complexity is o of n. It takes n times to travel. So to reduce the time within how fast we can access the data, to reduce the time, searching time, we used to find this time complexity to reduce the time, to make the code more efficient. Same like that space complexity also, like storage for data is more, means we have to reduce the space. We have to reduce the space and store it in as much as small as possible. For that we used to find space complexity. Now let's see how to find time complexity. See, first I'm having an array of size n. Suppose n is 5. Now see, 0 1 2 3 4. You have now size of array is 5. Suppose now there are 5 elements in this: 7 8 3 2 6. Suppose these elements are present in this array A. Now you want to search an element in array. Now I am writing a code for that. See, for I equals to 0 comma I less than n comma I plus plus. I'm traveling from 0 to last index. That's why I'm writing this loop condition. Then if a of I equals to data, print found. What is this? If a of data equals to data, then print found. I'm moving from 0, then 1, then 2, then 3, then 4 till last index. I'm moving one by one. Then if I found the data in that index is I'm searching, suppose 6, I'm searching, I want to search 6. If I find 6 in that, I'm writing it's found, 6 is found in this array. To search an element, this is the code. Now see, I'll find the time complexity for this code. Time complexity is how much time it takes to run this code till its completion. Now see, the simplest method I will say first. See, here for loop is only one loop. Only one loop is present here. For loop. So one for loop means it is O of n. Time complexity is O of n. If only one loop is there, then the other way to find the time complexity is analyzing the code. Let's analyze the code. See, I is at 0, I is at here now. Now I am searching whether a of I equals to data, whether 6 equals to 7, no. So I am increasing I plus plus. Now I is pointing towards this. I am checking whether 8 is equals to 6, no. So I am moving I to next position. Then whether 3 is equals to 6, no. So I am moving next to position. Now whether 2 is equals to 6, no. So I am moving next to position. Whether 6 equals to 6, yeah. So I am writing print found. So how much time it took? It took 5 times, because 5 index are there. 5 elements are present, so it took 5 time is 5. So what is 5? 5 is n, that is size of array. So time complexity is O of n. You can write like that by analyzing the code. Now let's find the space complexity for this program. Now see, space complexity is how much data is used, how much elements are stored in this data. That is n is 5. Suppose 5 data are stored. N is size of array. So it depends on size. So I am writing space complexity. Space is also O of n. Because y means it took we are defining this array on basis of n, that is size of array, and the space is 5. 5 is what? N. So we are writing O of n. Now let's see other example. Now I'm taking a matrix example. Suppose I'm storing elements in matrix n cross n. N is 4. Now see, index 0, 1, 2, 3. Here also 0, 1, 2, 3. Now I am storing elements here. Suppose this elements I am storing in this matrix. Now let's find how to find time complexity and space complexity for this matrix. Now I am writing the code. See, for wait for I equals to 0 comma I less than n comma I plus plus. What is this I loop? I loop is for traveling from for rows. You are traveling in zeroth index, then first index, then second. That is first row, second row, third row, fourth row. For traveling in row, you need an index. That is I. I am writing a loop for traveling from 0 to 3. Then I am writing another loop for j equals to 0, j less than n, comma j plus plus. What is this loop? J. J is for traveling in column. That is J is for traveling in column. In each row you used to, in first you are in first row means you are traveling in first row every column. Then you are traveling in second row you are traveling in every column. Like that. So I am writing another variable j for traveling in columns. That is j equals to 0 till j less than n, j plus plus. Now I am writing the condition for searching an element in array. Suppose I am searching 20. Suppose I am writing the condition. If A, suppose this matrix name is A. So I am writing if A, I, J. The cell in the matrix is represented by Aij. So I am writing Aij. If Aij equals to data to be found. Suppose data is 20. Suppose I am finding. If I found the data, then I am writing print found. This is the code for finding a element in a matrix. Now see. Now I should find the time complexity for this program. The simple method is finding how many loops are there in this code. See, there are two for loops. So if two for loops is there means two for loops. It means it is O of n square. This is time complexity. Now other way for finding is analyzing the code. You can find the time complexity by analyzing the code. Let's see. Now see, you are in I equals to 0. You are in first row. In first row, you are traveling every column. That is j equals to 0, then j equals to 1 till it's less than n. Now I am in 8. This position. Now I am checking whether 8 equals to, now 20 you should search. Now I am checking whether 8 equals to 20. No. Then I am moving this j. Whether 3 equals to 20? No. Whether 7 equals to 20? No. Then whether 6 equals to 20? No. Then I am moving this I to 1. Then I am fixed this row. Then I am moving every column in this row. Whether 1 equals to 20? No. Whether 5 equals to 20? No. Like that I am moving every column. Then in second index I am third row I am pointing, fixing. Then in this I am traveling every column and searching whether 20 is present? No. Then here also I am fixing and I am checking every column. At last you found 20. So how much time you took here? You have n number of rows. In n rows you will travel n columns. So the time complexity is O of n into n. That is O of n square. This is how you find the time complexity. Now let's find the space complexity. Space complexity. Now you define the size of array by n. N is 4. So this how many elements are stored in this matrix, or how much storage you need to store this elements in the matrix. 4 into 4, that is 16. 16 elements are present here. So I am defining the size using n. So n into n. So I am writing space is O of n square for this matrix. Now if you see this O of n, that time complexity for this program linear search, O of n is less than O of n square. This time complexity for this is more because you are traveling every column in each row. But in this you are in only one row. In one row you are traveling every columns. So time is less in this linear search. That is O of n. like this. For finding for reducing the time, like for reducing the time complexity, we used to find time complexity in every programs which we do, for making the code more efficient. That's why we use this time complexity and space complexity. Now let's find the time complexity for this four programs. Now see, let's find the time complexity for first program. Now this is a swapping program, swapping x and y. This is swapping program. Now I am going to find the time complexity for this. Now here int x, I am declaring that x. So for this no time is taken. For declaring the variable, no time will be taken. Now in next step, t equals to x. I am now in this, I am setting the t variable as x. Now I am fixing x in t. So this takes one time, single time. And here I am setting x as y. Now in x place I am putting y in that. So this takes single time, one. Now this, and now in third step I am fixing y equals to t. I am placing t in y position. So this takes single time. So total, you should add total how many time it took. Total it took 1 plus 1 plus 1 is 3. What is 3? 3 is n power 0. Because see, 3 means it's constant. Constant means it's single time. It does not depend on size of array, that is n. It does not depend on that. So it's constant. N power 0 is also constant. That is 1 is constant. So I am writing here O of 1. Time complexity for this is O of 1. Now let's find the time complexity for second program. Now this is a program which is used to find sum of an array. Now see, now in this I am declaring variable I, that is integer I am declaring. For this no time is taken. Now in this step, second step, I am writing fixing s is 0. So here I am fixing, so it takes one time. Now next step you find, this is for loop. For loop, here it starts from 0. It starts from 0 and it goes till n. It travels till n. At n it fails because it should be less than n. So it travels from It travels from 0 to n. At n it fails, so it travels. This inside statement will get from 0 to n minus 1. This is the condition. So see, this code will go from 0 to n. At n it will fail, so it will travel till n. So this 1 to n means n. This is 0 to n, so it is n plus 1. So time taken for this statement is n plus 1. Now inside this for loop travels, it takes n time. Why n time? See, this took n plus 1 travel, but in n plus 1 the code fails. At n only, till n only this thing works. So this time is taken n times. Now you should now for this return yes, this takes one time. Now you should add this totally. This is 1 plus 1 2, then plus 1 3. So I am writing plus 3. Then here n plus n 2n. So this is 2n plus 3. Now what is the higher order in this? This is n order. So I am writing O of n. Time complexity is O of n. Now see, in this case the time complexity is constant. It's O of 1. This O of 1 is less than O of n. So this code will perform faster than this code. Time taken for this code to complete is faster than this code. Now next let's see the time complexity for this code. Now this is the function add. Now this function is about adding the two matrices. Let's find this time complexity for this. Now I am declaring I and j. For this no time will be taken. Now this is the loop. For I equals to 0, I less than n, I plus plus. Now it starts from 0 to n. It travels from 0 to n. At n it fails. So but it travels from 0 to n, right? So I am if it travels from 1 to n, time taken is n. But here it starts from 0. So I am writing this n plus 1. Time taken for this is n plus 1. Now this inside another loop is that j loop for j equals to 0, j less than n. See, this inside thing will work till this till n times. See, this I loop is going from n plus 1 times it goes. At n plus 1 it fails, so this gets printed. This inside thing will get access till n times, because n plus 1 will fail. N plus 1th iteration will fail, so this code will get access till n times. So I'm writing here n times, this is n. Then I'm writing into this. What is this? This is a loop. This loop travels from 0 to n, same as this. 0 to n means n plus 1 times, so I'm writing n plus 1. So this is n into n plus 1, because this inside code will work till n iterations. At n plus 1 iteration it fails, so I'm writing here n. Then this is a loop, that's why it travels from it travels till n plus 1 iteration, so I'm writing n plus 1, n into n plus 1. Next, let's see this code. Now C of I j equals to a of ij plus b of ij. This takes n into n. Why n into n? Because see, inside loop, that say this code travels n plus 1 times. This is n plus 1 times. So this code works till n. So I'm writing 1n here. Then here another loop is that I loop, that travels till n plus 1. So this code works till n. At n plus 1 it fails, so it travels till n. So I am writing this n. So n into n, n square. This is n into n. Next, let's calculate this total time complexity. Now see, this is n. Now I'll write it here as n square plus n, because I'm calculating this. Now see, this is also n square. N into n, n square. Now see, n square plus n square, 2n square. 2n square. Now this is 1n, this is 2n, so plus 2n. Now plus 1. Now what is the higher order in this? N square. So time taken is O of n square. Now let's find the time complexity for this program. This program is starting from here. Now I'm calling the function func. Now inside this another function is called function 1. That function 1 is declared here, so I'm calling this. Now inside this function 1 there is a loop for I equals to 0, I less than n, I plus plus. Here it travels from 0 to n, it travels. At n it fails, so the code inside this works from 0 to n minus 1, but this travels from 0 to n. At n it fails, so this will be 0 to n. 1 to n means n times, 0 to n means what? N plus 1. This is n plus 1. So the code is O of n. Time complexity is O of n. This is the code for this is the time complexity for this thing. Next, let's find the order for time complexity. Like what is the order? Now see, now for the lesser time complexity is O of 1, because it's constant, it takes single time. Then the greater than this is O of log n, log base 2 or log base 10 n. This is used in tree structure. We will discuss in later class, like tree or like binary search, like that. We have an array. In that array we are splitting into two, and we are searching one part. Then in that part we are again splitting into two and searching another one part. Suppose see, this is an array and this is splitted into two. In this first one we are searching an element, and again this is splitted into two. Now I'm taking this part, second part. Now this I'm searching. This is again splitted into two. Then in this part I'm taking. So it's again splitting half by half. That is O of log n. In that search, this is the time complexity. Now next greater, let's see. Next greater time complexity is O of n. That is used in linear search. Like we have seen earlier, like in the statement, we can use time complexity is O of n. Then the time complexity is O of n square. This is used in like matrices and all for searching every elements in a rows. Every rows we are searching every columns. For that it's used O of n square. Then O of 2 power n. This is 2 power n is used in like recursion programs. Like in recursion programs, while calling the same function is called multiple times. In that case, this is the every calls is repeated twice. So that case it's 2 power n. So the order is O of 2 power n. This is the order of time complexity. That's all for today, and thank you. If you feel my teaching is good, then like my video, and if you have any doubts or if you want to give any suggestion, then comment on my video and share my video, and don't forget to subscribe my video. Thank you.